Bismillah ar-Rahman ar-Rahim. In the name of Allah, the most gracious, the most merciful. Today's A-level live lesson is a continuation of proof by contradiction, which, just to recap, means that you're trying to show something is wrong, and then if there's only two possibilities, so imagine the only two possibilities are that you have a circle or a square. If you can prove that it's not a circle, if you can prove that it's not one of them, the circle in this example, then you've automatically proved that you must have the square. So sometimes it's easier to prove something is true by taking the other possibility and showing that one is wrong, because then you're only left. Sometimes it's easier to prove something, show something is wrong, than to do all the work in showing something is right. So let's see how that works out. We're going to do example 2 from yesterday again, because I didn't quite write the question correctly, so that might have confused a couple of people when they watched the video. So the question is prove by contradiction. So we're trying to develop a mistake or an error to show that one of the two possibilities is wrong. What do we want to prove? We want to prove that if we have a square number, we're going to call it n squared. So if we have a square number and we know that it's even, then we want to prove that n has to be even. So that's the slight correction from yesterday. We want to prove that n has to be even. The number, so in simple words, take a number, square it. If you see that the number you're going to get is even, then can we prove that the number we started with is also even? So here we think, well, rather than do all the work of proving that n is even, let's do it the other way. Let's try to prove that it can't be odd. So let's start with saying that n is odd. Let's say n is odd. And if we can somehow develop a mistake or an error, and that way show that it can't be that n is odd, then we've automatically proved that n must be even. So let's say n is odd. Then if we remember from year 1, we can write odd numbers as a multiple of 2, add one more, so that will make sure it's an odd number. Then because we're trying to get a square number, we can say that n squared is going to be 2k plus 1 squared. So that just means 2k plus 1, I'll write it out, 2k plus 1 squared would be n squared. But we know what 2k plus 1 squared really means. It really means that we've got the bracket twice, so I can write that as 2k plus 1 twice. That's what this little 2 really means, so I can rub that out. And then if I expand that out, hopefully you watched yesterday's and you're comfortable with squaring brackets, but that works out to be 4k squared plus 2k plus 2k plus 1. I'll just put the squared in there. And the middle 2k plus 2k, we can simplify that to 4k. And now we just want to do a bit of factorizing, because we know that as soon as we get a multiple of 2, then that's an even number. So it looks like the first part, 4k squared plus 4k, that can be factorized with a factor of 2 at the beginning. So let's bring the 2 out. So we've got 2k squared plus 2k. That's your first two parts. and then we've got the plus 1 hanging at the end. So now if we examine that, because the first bit is a multiple of 2, so that has to be even. Plus 1, if we take an even number then add 1, then that means we're going to get an odd. So what we're saying is that if we start with n is odd, then we're going to get n squared to be an odd number. But I was told in the question that n squared is even. So to get n squared as even, it can't be that we should start with an odd number. So we've proved that there's no way you can get a square number at the end that's even if you're starting with an odd number. So what's the other possibility? The other possibility is that you must start with an even number. Okay, hopefully that made a little bit of sense. Let me just quiz you on that. If you can tell me from the proof that we just did, what was the first step we do? We're trying to prove that n squared, if we're trying to prove that n, the beginning number, must be even. And we're using the proof by contradiction method. So can you type in the chat window, what's the first step we take? Okay, looks like you're struggling a little bit there. But the first step is, because we're trying to prove by contradiction, contradiction really means we want two things to oppose each other. So the way we're going to try and do this is we're going to pick the opposite of what the question is telling us. The question is saying that n must be even. Well, let's pick the opposite, which is let's assume n is odd. Okay, fine. Where do we go from there? Okay, from there, if you remember, we just follow the question. Question's talking about square numbers. So we want to get to a square number, but we're also talking about odd numbers and even numbers. So we remember that an odd number can be written as a multiple of 2 plus 1. Then we square it. Then we examine it and say, okay, do I have an odd or even number here? Well, I know that once I've expanded it and simplified, the beginning bit can be written as a multiple of 2, plus the 1 at the end means I've got an even number, the multiple of 2, plus the 1 at the end makes me end up with an odd number overall. So my square number is odd, and I started with an odd, but the question said that I wanted to end up with an even number. So since it's not possible to get an even number at the end by starting with an odd number, it can't be that the beginning number is odd. It must be even. Okay, let's go on to something slightly harder, which is talking about irrational numbers, and we want to prove that root 2 is an irrational number. Again, we want to use a contradiction. So we start with the opposite of what the question is telling us. Prove root 2 is an irrational number. I'm going to start with my first assumption that I'll hopefully then show is wrong, which is the opposite. What's the opposite? Let's assume that root 2 is a rational number. And then just follow the maths, see where it takes you. So let's assume root 2 is a rational number. That means root 2 can be written as a fraction of two whole numbers. Let's call them a over b. And these are the simplest numbers you can have. It's a fraction that can't be simplified more. Now that's root 2, so we can easily get rid of the square root by squaring both sides. So I'll have just normal 2 is equal to a squared over b squared. Square both sides. Now because I've got a square number, but it says a fraction, it might be easier to work with it when it's not a fraction. So let's take the b squared onto the other side. Let's multiply by b squared. So now I've got the fraction that's gone away, that's disappeared, and I've got something that's easier to look at. Let's swap the sides around. And what I see by just doing that little move is that now I've got a multiple of 2. So a multiple of 2 here means that I've got an even number. So I see that a squared must be even. I'll put the 2 in a sec, the squared in a second. So a squared must be even. So if a squared is even, then based on what we just did, we know that the number that made it has to be even as well. That's from the previous proof. So then I can say that a has to be even. So it's got to be, a has to be even. So that means I can write it as a multiple of 2. Let's just call it, I could use k again like before. So I could say 2k. So from there, can we say that anything about b? Well, we could put the 2k, substitute that for the a. So we can have 2k squared is equal to 2b squared. Let's expand out the brackets. So that's 4k squared equals 2b squared. Just put the square signs in. Both sides look like they can be halved. So you've got a 4 here and a 2 here. So if I divide by 2 on both sides, I'm going to be left with 2k squared equals b squared. And what does that tell me? Let's swap the sides around. So I've got the b squared on this side, on the left. So let's take that around to here, just like I did before. So I've got, before I said that a squared was even, because it's a multiple of 2. Well, I can say the same thing about b squared. It's got to be multiple, it's a multiple of 2. So that means b squared is even. And if b squared is even, that's a square number that is even, then the number that made that square number is also even from the previous proof. So I've ended up with a has to be even, b has to be even, but what I said before, but if a and b really were even, then I could simplify that fraction. If you have a fraction where both numbers are even, then you can divide both by 2 and you'd get two new numbers that were simpler than the ones you had before. But when I said that root 2 is a rational number, you can only have a rational number if you've got a fraction where both numbers are whole numbers and they're the simplest possible. That's your definition of a rational number. So you can't have something that's the simplest possible fraction and then find out later that both numbers can be divided by 2. That's your contradiction. So if that means if you've got a contradiction, it means that what you started off with has to be wrong. Root 2 is a rational number is what we assumed. That's got to be wrong. It can't be a rational number, so we've proved it's an irrational number. Okay, let's just quickly go through that, see if you managed to catch any of those steps. Okay, it was a bit of a long proof and my undo's run out, so I'm going to just carry on from there for you. You're going to carry on from there, just give you a little bit of a head start. So our first step was we took the opposite of what the question is saying. Trying to prove it's an irrational number, let's assume it's the opposite. Let's assume root 2 is a rational number. What does that mean? It means we can write it as a fraction. That's two whole numbers, a and b, and they can't be simplified. That's the part of the definition of a rational number. It can be written as a fraction with two whole numbers that can't be simplified any further. What does that mean? It means that if we've got it's a little equation, root 2 is equal to a over b, and we can manipulate that equation. So first thing we're going to do is try to get rid of that square root sign. So we square root both sides and we get rid of the square root, and we have squares here and here. And then we can take the b squared over to the other side. So now we end up with 2b squared equals a squared. So the question to you, if you are following this, what did we do next? Give you a few seconds to think. Add 1 to the last, that was the previous one. So what do we do in this proof? What do we do next? Okay, just to remind you, we just rearrange it a little bit so we have the a squared on the left. Now it's easier to look at and easier to see that it's a multiple of 2. So as soon as we see it's a multiple of 2, then we know it's got to be an even number. That means our square number here, a squared is a square number, is an even number. Next, we really want to try and think of saying something about a. If we know what a squared is, it's an even number. Can we say something about a? Yes, based on the previous proof. If you have a square number that's even, then the number that made it has to be even, so we can say a is even. What do we do after that? Well, we said that any even number means that it can be written as a multiple of 2, so a can be written as a multiple of 2. And then let's square that, because we're dealing with a squared, or let's substitute it into a squared. So we end up with 2k instead of the a being squared is equal to the 2b squared. Expand that out a little bit, and we end up with 4k squared equals 2b squared. Then what? What's so special about that? See if you can write it down. nothing special yet, but what we can do is simplify it a bit, divide both sides by 2. So 2k squared is b squared. Keep the b squared on the left, like we did before. Now we can see immediately it must be an even number. It's a multiple of 2. So b squared is even. A square number being even can only happen if the number that we started with is even, from the previous proof. So now we've shown that a is even, b is even, and if we go back right to the beginning, if we have a fraction with an even number on the top and the bottom, that means it can be simplified. But a rational number has to be written as a fraction that can't be simplified. It's got to be in its simplest form. So we can't have both. We can't have a over b in the simplest form and then later on say that, hold on, a and b can be divided by 2. That just is a contradiction. So what we started with was wrong. It can't be that root 2 is a rational number. It's got to be an irrational number. Okay, hope you enjoyed that, and see you next lesson, 9 p.m. Monday to Thursday, inshallah, if God wills. Assalamu alaikum wa rahmatullah. Peace be with you and the mercy and blessings of God.